This video will cover the 8.D note on parabolas. Okay, parabolas are something that you've seen before in Algebra 1 and Algebra 2. You graph them in standard form and vertex form. We're going to graph them in what's called conic form and look at some characteristics of parabolas that we haven't looked at previously in math. Okay, so this is what we call conic form. All right, y minus k squared equals 4p times x minus h, or we can switch them and have x minus h squared equals 4p times y minus k. The difference is when the x is squared, which is what you're used to seeing for parabolas, you're used to seeing, y equals 2x squared plus 3x plus 6 or whatever. When the x is squared, the parabola opens up or down, just like you did in Algebra 1 and 2. But here where the y is squared, now it's going to open to the right or left. So now we can have sideways parabolas. So first we're going to look at the key characteristics. The vertex, just like the center in a circle or ellipse, the vertex is HK, the opposite of whatever is in the parentheses. Then we have the axis of symmetry. Okay, if you remember from Algebra 1, this is the line that goes right through the middle. Okay, so if it's an x squared parabola, so it's an up and down parabola, then the axis of symmetry would be x equals h, because it's a vertical line, so it's x equals, and it has to go through the vertex. If it is a y squared parabola, so a sideways one, now the axis of symmetry has to be a horizontal line, so it's y equals k, which is the y-coordinate of the vertex, because it always has to go through the vertex. Okay. The focus we're going to find using P. All right, and the focus is going to be a point that's inside the parabola. And focus and directrix kind of go together. The directrix is a line, and it's going to be found by negative P, so it's going to be the opposite of the focus. So we'll look at this when we graph them, but the focus is inside. It's a point inside the parabola, and the directrix is a line that is outside the parabola. Okay, so that's what it looks like. Then we have something called the lattice rectum, and what it is it's a line that has endpoints on the sides of the parabola, and then it goes straight through the focus. Okay, we're going to use that to find points to graph. Because in conic form it's a little bit difficult to plug in numbers. So the length of the lattice rectum from your equation is 4p. So when you have an equation in conic form, 4p is going to be the length of the lattice rectum. It is always going to be the absolute value. Okay, so even if 4p is negative in the equation, when you write the length of the lattice rectum, it has to be positive because we can't have negative lengths. Okay, so let's look at some examples to graph. When we graph parabolas in conic form, you're going to graph the vertex first. Okay, so one is the vertex, and then the second thing you're going to graph is the focus, and then we'll use the lattice rectum to find two more points. Okay, so if I look here, there's nothing in parentheses, so that means my vertex is at 0, 0. Okay, I have x squared, so that means I'm just going to make a note to myself that it's either an up or down parabola. Okay, so there's my vertex. Now I need the focus. The focus is P. Whatever number is here, that's the coefficient of the non-squared term. So y isn't squared, the coefficient of y is 8. That is 4p. Okay, if you remember from your equation. So if 4p is equal to 8, then p must be equal to 2. Okay, so that means my focus is going to be 2 spaces away from the vertex. Because it's an up and down parabola, and p is positive 2, I'm going to go up 2. So there is my focus. Okay. Then we're going to use the lattice rectum to find the other 2 points. So if my lattice rectum is 8, all right, that means that there's a line that goes through the focus that has a length of 8. The focus is the exact middle, so what I'm going to do is cut this line in half, and in half it would be 4, so that means it's 4 to the right, 4 to the left, because now from here to here is going to be 8. 4 plus 4 is 8. So we cut it in half, count that way in either direction, and that gives me the points for the other side of the parabola. All right, so that's what that would look like. That's graphing in conic form. And we're going to go ahead and identify all of those pieces that you're asked for. So the vertex, all right, is first, and the vertex in this case is 0, 0. Then we need the axis of symmetry. Remember, that is the line that goes through the middle, so in this case it's a vertical line, so it's x equals the x coordinate of the vertex, so x equals 0. Then I need the focus. Okay, focus is a point, so it's an ordered pair, 0, 2. The directrix, which we need to draw on here. Okay, remember I said the focus was P and the directrix is going to be negative P. So for the focus, I went up 2. That means for the directrix, I'm going to go down 2. So it's going to be a line here. All right, it's a horizontal line, so it's y equals negative 2. It's always the opposite direction from the focus. So up 2 for the focus, down 2 for the directrix. All right, and then we need the length of the latus rectum, and that is, remember, 4p, so this is 8. Let's graph this second example. This time I have y squared, so I know it's going to be a sideways parabola. Okay. Vertex is the opposite of what's in parentheses, so I have negative 1, negative 1, so that means my vertex is going to be at 1, 1. Okay. Then again, the coefficient of the non-squared term, so x is not squared, so its coefficient is 4, that is 4p. All right, so if 4p is equal to 4, then p has to be equal to 1. All right, and again, this is a sideways parabola, so positive 1 means I'm going to go right 1, and there's the focus. Okay, the latus rectum has a length of 4, so if I cut it in half, it would be up 2, and then down 2. Those are the points on my sideways parabola. That's going to look like this. Okay, again, let's go through and list out all of these things. So the vertex is right here at 1, 1. The axis of symmetry, remember, is a line through the middle, so in this case it's horizontal, so y equals 1. Focus, all right, is this point, so it's at 2, 1. Directrix I need to draw, so I went right 1 for the focus, so I'm going to go left 1 for the directrix. So that line right there would be x equals 0, and then the length of the latus rectum is 4. The other thing that we need to be able to do is sometimes the equation is not given to us in conic form, so sometimes we have to change it. To change it to conic form, what I need to do is get the squared term by itself. So I want this x minus 6 squared on one side and everything else on the other. So I'm going to add 1 to both sides to start. Y plus 1 is equal to negative 2 times x minus 6 squared. And then the last thing I'm going to do is divide by negative 2. Okay, now I don't want it to look like this. I also don't want to divide both of these things by negative 2 because I want it in my conic form, and remember that was 4p times y minus h. Okay, so or y minus k, sorry. So to get it to look like that, I want this y plus 1 to stay in parentheses. All right, and remember, if there's no number, we say that it has a coefficient of 1. So really, if instead of dividing by negative 2, I'm multiplying this by negative 1/2. So I have negative 1/2 times y plus 1 is equal to x minus 6 squared. So now that is in conic form, and now it can be graphed. This example I'm going to change actually a little bit. We're going to make this negative 1/2 out in front. So again, we're trying to get the squared term by itself. So if I add 3 to both sides, I have y plus 3 equals negative 1/2 times x minus 5 squared. To get rid of negative 1/2, I can either divide by negative 1/2 or I can multiply both sides by negative 2, because remember those are the same thing. So I'm going to keep this in parentheses because that's what it looks like in my formula. So I have negative 2 times y plus 3 equals x minus 5 squared, because this negative 1/2 times negative 2 would cancel each other out. So that's how we get things in conic form. Sometimes you have to do that before you graph. And that is all for parabolas.